In this video, I am going to explain how to train a UNET deep learning model. Normally, I would start with a pre-trained model. However, a pre-trained model does not exist for this type of sample. First, I will select the Count Size tab. Next, select the Model Manager. imagepro includes a number of pre-trained models. The available pre-trained models are based on the base UNET, CellPose, and star disk architectures. Since I would like to measure an area and not individual objects, I will use the base UNET architecture. These models are very specific for the types of samples the model was trained on. To train a new model, select the New button in the Model Manager. Since I am looking for an area, I will set up the model using UNET. In step 1, select Semantic. In step 2, the image is monochrome. In step 3, the background will be used for the unlabeled pixels, and I'll add one class. Here I can set the class color and other display parameters. In step 4, the model is already set to base UNET since I selected semantic segmentation. In step 5, I will use the default training options. And in step 6, I will name the model, assign an industry model for later searches, enter the description as needed, and the model will allow you to include a demonstration image for training or demonstration purposes. The optional snapshot will be displayed in the Model Manager. Finally, I will load a model in the AI Trainer. Press the OK button to continue. In the AI Deep Learning Trainer, the class is named and the display options are set. Additional classes can be added, but they must be added before continuing the training. ROIs allow you to define smaller areas for creating labels for the training. There are multiple segmentation tools available to label or mark up the image for training. There are available tools here in the draw manual such as brush, polygon, and the magic wand. In addition, we can use smart segmentation or manual threshold. And finally, we can predict with an existing model. For this example, I'll use the magic wand. Once I've selected an area with a wand, I can then refine it using the histogram to fully select the layer. Once done, press the green Validate button. As you'll notice, the training sources are now populated with one label. And now I can add that label to the training set by pressing the Add button. The Add Labels gives you information about the image, just to confirm this is the proper information you want to add to the training set. Simply press Add and it will complete adding the labels to the training set. Next, I like to label another image. Again, I'll repeat the same steps and use the magic wand. And then finally, adjust the parameters to dial it in a little bit better to get the final result. Once I'm happy, I need to press the Validate button and add the data to the training set. To train, simply press the Train button. As you'll see, the information is added to the training set. By default, there are 300 steps and 30 epochs. To start, simply press the Start button. You can monitor the training stats in the AI Deep Learning Output panel. As you can see here, as it continues through the epochs, when enough epochs have been completed, it may be easier to monitor the progress by looking at the training graph. Here, the loss versus the number of epochs is displayed. When the training is complete, press the Predict button in order to test the new model on an image which has not been used to train the model. The newly trained model has been loaded in the AI Deep Learning Prediction panel. From here, we can test an image that has not been used for training. Simply confirm the classes, the segmentation channel. There are no options in the base UNET to set. Simply press the Count button, and the results will be displayed. In this particular case, the small areas that are selected can be filtered out when we set up the final workflow. However, please note that the layer has been correctly found. Additional training may get rid of those small errors. Thank you for watching this video. If you have any questions, please contact Media Cybernetics and we'll be happy to help.